Okay, folks, so in this problem, which is the next one in our section, we're asked to compute the derivative of the function f of x is equal to x cubed minus x. So you really have all the tools you need to do this, for you to do this problem. So I encourage you to pause the video and try to do it on your own. The only hard part, I think, or the hardest part, is cubing out this this expression here in the limit definition of the derivative. But I encourage you to pause the video and give it your best shot on your own. All right, I hope you paused it and I hope you gave it a shot. But let's go ahead and dive into it. So f prime of x is equal to what? Well, let's just jump straight to the limit definition. This is the limit definition. Oops, close enough. As h approaches 0, of f of x plus h minus f of x all over h. So all I've done here is given the limit definition. In this next, or in the next line, what I'm going to do is I'm actually going to apply the specific function. I'm going to give the definition of the function. So this would be x plus h quantity cubed minus x plus h. All of that is our f of x plus h minus x cubed minus x all over h. Okay. So now I'm in the process of evaluating this, and I sort of have a gut feeling as to how things are supposed to work. I expect I'm going to expand this out. I expect that I'll be able to cancel a lot of terms, and then I'll eventually be able to factor out an h and cancel this factor right here that's preventing me from doing direct substitution on this limit. So I'm going to go ahead and cube out x plus h cubed. I encourage you again, even if you didn't pause the video before, to pause it now and cube out x plus h on your own. And in class, maybe I'll show you a shortcut for doing that trick. So if we were to cube this out, we'd get x cubed plus 3x squared h plus 3x h squared plus h cubed minus x minus h minus x cubed plus x, all in our numerator, all over h. So folks, just I did that a little bit fast. This part right here was this expression raised to the third power. And then this part right here is this expression. And then what remains is this expression right here after I distribute the negative. So as we suspected, things are looking pretty good. In this case, notice that the x cubed terms cancel. So I've got a 3x squared h. Notice that well, that term doesn't cancel, so we have 3xh squared plus h cubed. We have an x term that cancels with this, so we get minus x minus h all over h. So that's what happens when you cancel out the terms. All I'm doing there is simplifying. Okay. Now I'll just preview something you're going to see in the video that you watched that Grant Sanderson does. He makes the comment that after you divide by what he calls differential x, after you divide by differential x, you will have a bunch of terms that might still have differential x's in them, and those all go to 0. We're going to see exactly how that happens in the limit, but just to kind of tie it into that video you're going to watch at the end of this section, this term right here has an h squared term. It has an h term that's higher than 1, as does this. So when I go to evaluate the limit, these two terms right here will vanish. Anyway, let's just see what happens. If you didn't follow that, that's okay. You'll get some more practice with it. So we've got the limit then as h approaches 0 of factoring out an h. Factored an h out of each of those terms. And then we can divide out those two h's. So we're left with the limit as h approaches 0 of 3x squared plus 3xh plus h squared minus 1. And now the factor h in the denominator that was preventing us from being able to do direct substitution has been removed from the problem. And we can now just simply evaluate this limit through direct substitution. And we get 3x squared plus 3x times 0 plus 0 squared minus 1. As I suspected, these had factors of h bigger than 1. And so notice that when we do the limit, those terms vanish. And we're left with a derivative of 3x squared minus 1. So the upshot is, for f of x equal to x cubed minus x, its derivative is 3x squared minus 1. And we did that using the limit definition.